Gas nebulae and radiation generally show comparable densities and circulations. The ongoing clarifications highlight vast expansion as of now. However, a few specialists put forward the proposition that this interaction really continues to this day, and that a huge number of parallel universes have formed in the process. The Big Bounce hypothesis, as a small in-between end, suggests that despite its overall acceptance, the Big Bang is anything but uncontroversial, and that we are still far from fully unraveling its background. Thus, over time, a few alternative theories have emerged that attempt to explain the question of the cosmic beginning in a completely different way. Regardless of whether these corresponding theories sometimes differ drastically from each other, they still share a fundamental commonality. We must forsake the idea that the Big Bang was the beginning of everything. If there was another universe before the Big Bang was merely the catastrophic transition from one universe to the next. Consequently, it would be better described as the Big Bounce. But what exactly does that mean? Are there any substantial pieces of evidence that support the existence of such a recurring universe? Well, in principle, the idea of the interaction between destruction and rebirth is anything but new. The early Indian Vedas, for instance, described the universe as a sequence of creation, annihilation, and recreation that repeats itself eternally. The Maya had a very similar perspective, and Einstein himself spent some time considering the possibility of an oscillating, recurring universe and thought it was quite possible. In line with the maxim, what expands can also contract again, cyclic models are still quite popular in cosmology today. This is hardly surprising, since this approach is able to dodge the problem of causality. If matter has always existed in an eternal cycle, the question of how something can arise from nothing is no longer relevant. In such a context, there has simply never been such a thing as a flat-out nothing. In this case, the strange consistency of the universe could also be explained by a big contraction, which distributes almost everything uniformly. The trigger for the Big Bang would be just as easy to find. It was simply the end of the previous cycle, which was followed by a new phase of expansion. So everything could be so simple, if not for the problem of entropy. According to the second law of thermodynamics, the degree of disorder in a closed system always increases. This also applies to the universe. Due to the ever-repeating cycles, entropy would therefore need to increase forever. This means that with each cosmic fresh start, a little more radiation is created relative to matter, and that the universe will eventually reach a state of maximum entropy where neither atoms, stars, nor galaxies can exist. But that's not all. Due to the entropy problem, more and more disordered particles would be packed together with each contraction of the universe, while the accompanying new beginning would be accompanied by a stronger dispersion. On the other hand, this means nothing other than that each new cycle would last slightly longer than the previous one. Relative to the past, however, this would also mean that the cycles are getting shorter the further back we look. Just as with the Big Bang theory, we would eventually arrive at an initial point where everything is concentrated, the singularity of the universe. So, can we now file the cyclic models away, given that these theories strongly rule out a primal beginning of everything? Well, we shouldn't dismiss the idea of an eternal cycle so quickly. In fact, scientists have now figured out how to address the entropy problem, and all it takes is a universe experiencing a severe form of memory loss. To understand what this means, we need to take a brief detour into the world of loop quantum gravity. According to this hypothesis, and contrary to Einstein's assumptions, the fabric of space-time is not continuous, but is instead divided into tiny unbreakable units. These anonymous loops have a scale of 10 to the power of negative 35 meters, which corresponds to the Planck length, and therefore the smallest possible unit in quantum theory. In other words, the interconnected loops form the basic structure of the universe, with particles representing the nodes of the network-like construction. In this way, we can imagine the universe as a web of constantly changing tiny connections that are neither visible nor tangible to us. In this context, the initial singularity of the universe could not have existed. Loop quantum gravity only allows for finite physical quantities, which means an infinite density is not feasible. At the same time, however, the quantization then causes an event that is no less tremendous. At the moment of the Big Bang, gravity is reversed. Instead of exerting an attractive force as expected, it suddenly pushes everything away. As a result, space is essentially turned inside out, which in turn has some surprising consequences. Accordingly, the loop model literally screams that the Big Bang was not the beginning of everything. Unlike the theory of relativity, it also yields concrete mathematical results before the Big Bang. So there could truly be a big bounce, where a predecessor universe collapses in on itself and is then pushed back into larger scales by the anti-gravitational effect of its own tiny network. Conveniently, the resulting fluctuations in matter and energy density would erase all information from the previous universe. In this way, every new universe experiences a severe case of memory loss, which also provides a solution to the problem of entropy since it is practically reset to zero. The universe can shed its old entropy tangles and start afresh. And now feel free to hit the like and subscribe buttons. Become a part of our community and never miss a new video from us again. We'll see you soon. Begun the path of the shining secret. Explicitly, they zeroed in on the question of whether the carbon at the center mantle limit of the youthful planet stayed as graphite, or whether the pressure was sufficiently high to pack it into a precious stone. The researchers put the most elevated conceivable strain at this limit at 7 gigapascals. So, in the course of the ensuing high-strain trials and displaying, it was important to figure out how unique creations of Mercury's material acted in this outrageous zone. The baseline was that there was not just huge strain here, but also temperatures between 1,700 to 2,000 degrees Celsius. As opposed to past examinations, anyway, the specialists added another fixing to the early Mercury recipe, sulfur, which we now know is additionally found in abundance on the little planet. In combination with the carbon-containing mixture of silicates and an iron-silicon compound for the core, the specialists accordingly obtained a combination that lowers the temperature at which the silicate melt of the magma sea begins to harden, due to the sulfur, and in an amazing miracle, with a sulfur content of around 11%, the temperatures and high tension at the lower edge of the magma sea are sufficient to change a small portion of the carbon into precious stones. Yet, while this shining layer is only between 0.1 and 200 meters thick on its own, it could have been significantly fortified by the core diamonds. As these diamond gems were lighter than the leftover liquid metal, they ascended to the core mantle limit, where they were stored and formed a precious stone layer that could be around 15 to 18 kilometers thick today. However, the natural jewelry box that encases a treasure is precisely difficult to open. The colossal gemstone store is hidden more than 600 kilometers beneath the planet's surface and is thus inaccessible. It is undisputed that the specialist's explanations sound incredibly thrilling despite this unavailability, but ultimately, it's simply a hypothetical presumption. Is there a way to actually see if Mercury conceals a diamond layer inside? Well, the answer is yes, but indirectly. This is because the gemstone layer is too thin to be detected from the outside or by indirect measurement techniques. However, it could be that some diamonds were brought to the surface by dissemination flows, volcanic activity, or large impacts in the early days of Mercury. This is a phenomenon that we are also familiar with from earthbound diamonds, which are carried along by the rising magma from volcanoes. And, of course, according to the specialists, the planetary expedition in the so-called high magnesium area looks especially promising around here. Messenger's examinations have revealed a surprisingly high magnesium content in the crust and thus given an indication that material from great depths once reached the surface here. Anyway, the future should show whether this also included diamonds, a future that goes by the name of Baby Colombo and, as mentioned, is set to take a close look at Mercury as soon as next year. Is there life on Mercury? Well, if Alexis Rodriguez has his way, this can no longer be ruled out. The lead author of the study, which was published in the Planetary Science Journal, points out in detail that Mercury and Earth are surprisingly similar in one regard. But what does that mean? There are, believe it or not, glaciers on Mercury as well. However, They are glaciers that are completely different from their earthly namesakes. What on Earth are still massive ice masses with a clearly defined catchment area are, on Mercury, salt streams that have trapped volatile compounds like water, carbon dioxide, or nitrogen far beneath the planet's surface. The discovery of the salt glaciers was triggered by messenger data, which had identified regions with raised concentrations of volatile elements. Moreover, some obvious pits and scar-marked structures show that substances once outgassed and sublimated there. In this regard, the specialists emphasize that their models strongly confirm that Mercury's glaciers were formed by a salt stream and contain volatiles for more than 1 billion years after their emplacement. And why does this aspect become so important to the specialists? It becomes clear when we return to Earth. Even in the most unwelcoming terrestrial regions, such as Chile's Atacama Desert, there are habitable niches made possible only by certain salt compounds. Considering this, it could be that Mercury also has underground areas that are much more hospitable to life than its harsh surface. Ultimately, however, the discovery of Mercury's glaciers also has much greater significance. After all, exoplanets like Mercury could have comparable features that make life underground possible. And if you now go underground to our video, you will find a button there that will enable you to never miss an amazing post from us again. So go ahead, press the thumbs up, and subscribe to stay up to date from now on.